All right, so the next thing we're going to talk about is what's called conjugate acid-base pairs. Conjugate acid-base pairs. They go together. If you have a conjugate acid, then you also have a conjugate base. Okay? A conjugate acid is defined as something that has gained an H. Okay? A conjugate base is something that has lost an H. All right? If we have, let's just say X. All right? Whatever that might be, and it doesn't have an H. No H plus ion. So it's not an acid yet. If we have an H, let me go ahead and a hydrogen ion get donated and it now has the H on it, it now becomes HX, then this would be called a conjugate acid, the HX. All right? I like to make the analogy, if I said I'd love to be able to donate $500,000 to the Red Cross. That'd be fantastic. I'd love to be able to donate it. But I can't because I don't have it. So an acid has to have an H+. An acid has to have an H+. I say I'd like to donate $500,000 to the Red Cross. I don't have $500,000, so I can't donate it. But if I gained $500,000, somehow I won the lottery and I gained $500,000, then once I gain that H or gain that 500,000, then I could donate it. So if something doesn't have an H, it's not an acid, but if it does gain an H, then it can be considered an acid, and it's considered a conjugate acid. Whatever would have lost that H is what we call our conjugate base. So let's take a look at examples, and really all it is did it gain an H or did it lose an H? Okay? So here's an example. In this case, this HCl is an acid. X is acting as a base, let's say, okay? So it's acting as a base. Because notice, this H, if we're talking about H plus Cl minus, this H gets donated here. Again, reminder that an acid can donate an H plus. A base is an H plus acceptor. All right? So if that H plus gets donated to the X, we now have HX. Notice that X did not have an H initially, but now it does. So we can call it our conjugate acid. The conjugate acid is the one that gains the H. The Cl in this case is the conjugate base. Why is it the conjugate base? Because it used to have an H, but it lost it. Notice that we don't have an H here, so now it's lost the H. So when we talk about acids and bases in the conjugates, then they kind of get paired up. And we like to pair our acid with the conjugate base and the base with the conjugate acid. All right, so if I ask what the conjugate acid-base pairs are, first you would want to know what each of them are: acid, base, acid, conjugate base, and then how they pair up. All right, so that's one example. Let me just quickly show you another. I might have a couple here. So there's that. All right, so same situation here. AlOH3 and H2O. If you're not sure whether this AlOH3, aluminum hydroxide, is an acid or a base, if you're unsure of that, notice what happens on this side. Notice that you have an H, AlOH3. That means that this must have gained an H. So this aluminum hydroxide is a base. H2O is acting as the acid. H plus, OH minus. Notice the H plus goes here, so we have OH left over, and then the H, AlOH3. And you can see why I put the H in front right away, because I've seen, if you don't put that H in front and you call it AlOH4, it's not correct, because you do have 4 H's, right? I have 1 and then 3 more, but I don't have 4 O's. I still only have 3 O's. So that's kind of why I wanted to, that's kind of why I like to put the H just in front. Anyhow, what are these things? Well, This one is the one that has lost the H, so notice it's the conjugate base. And the one that has gained the H is this one. There it is right there, so that's the conjugate acid. If I talk about my pairs, the base goes with the conjugate acid and the acid goes with the conjugate base. So there's conjugates.